Let's take a look at a couple of practice problems. Let's do Chapter 2, number 17, and let's start with A. The problem for A says, solve each of these equations for x. Now, because we've practiced our dimensional analysis, we know that if we divide both sides of this equation by 3.42, this cancels out and becomes 1, leaving us x on this side, and then 6.5 divided by 3.42 on this side. A quick calculation with our calculator tells us the calculated answer is 1.9005848. Oh my goodness, that is a huge number. What are we going to do with a number that big? Well, we're going to need to use our significant figures. We take a look at this and we see very clearly that this number right here has 2 significant figures. This one has 3. When we do a multiplication or a division problem, we always do the less accurate of the 2, meaning our answer is going to be 1.9. That's going to be the correct number of significant figures. So let's review. We started with 3.42, x equals 6.5, and we wanted to solve for x. We divided both sides of the equation by 3.42, giving us x equals 6.5 divided by 3.42. We plugged that into our computer, or our calculator, got an enormous number, but we remembered that with multiplication we always use the least number of significant figures, meaning we were only going to have 2. Our final answer then is x equals 1.9. Let's do another example. For number 17, problem B, the problem said x divided by 12.3 equals 7.05. Solving this equation for x, we multiply both sides of the equation by 12.3. That cancels out here. We have x equals 7.05 times 12.3. Again, we plug that into our calculator and we get 86.715. Now that number has 5 significant digits, but here, our first value here has 3. Remember that 0 is significant because it is in between 2 whole numbers. And this one also has 3, so we need to round our answer to 3 significant digits. That's going to make our answer x equals 86.7. That's your final answer for letter B, number 17. Now that we've got a handle on that, why don't we try problem number 19 and look at 1 or 2 of those. So problem number 19, let's do letter A. Okay, it wants us to convert 28.0 centimeters to meters. We know that we need to go from centimeters to meters, and we need some conversion factor. If you take a look at the book, we know that 100 centimeters equals 1 meter. That is the conversion factor you need. So you start with what you were given, 28.0 centimeters, and then we know we need to multiply by the conversion factor. Well, we know 100 centimeters equals 1 meter, but we need to get rid of this centimeters right here. So what we're going to do is we're going to multiply this by 1 meter over 100 centimeters. Now, how did we get that point? Well, let's take a look how we get that. So let's take a look at the conversion factors and how we can do this. We know 100 centimeters equals 1 meter. Now if we divide both sides of this equation by 100 centimeters, we know that a number divided by itself is always 1. So we know this conversion factor equals 1. We can multiply it by anything. We can multiply it by x, 5,014.7, and it's really just multiplying it by 1. All we're doing is converting the units from one thing to another. Alternatively, we know 100 centimeters equals 1 meter. We divide both sides by 1 meter, This again is equivalent to 1. This, if you multiply and plug it into any equation, if you're trying to cancel out units and convert them, is equal to 1. You just plug it in. So let's see how it works in our problem. So that is why we chose to use 1 meter over 100 centimeters, because we are going to use that to cancel out our centimeters and result in meters answer. When we do that, we end up with 28.0 centimeters times 1 meter per 100 centimeters. Crossing that out, we have 28.0 divided by 100. Move my screen up a bit. A quick calculation, and we find out that 28.0 centimeters is equivalent to 0.28 meters. It's just that simple. Let's try converting between different units. We'll go to an American metric conversion. Let's look at problem number 21, and let's try, I don't know, how about letter C? C is a good example of a tough one. We start with 2.00 inches squared. That would be like an area, like a length times a width. And we want to convert that into square centimeters. Now this is going to be a multi-step problem, but don't get overwhelmed. You can do it. First we need to figure out what the conversion is between inches and centimeters. A quick look in our textbook tells us that 1 inch is equivalent to 2.54 centimeters. Alright, so let's figure out how we need to set up this problem. We're going to start with 2.00 inches squared. What does inches squared mean? That means 2.00 inches times inches. I didn't show it very well, but I hope you can read it. So it doesn't mean 2.0 squared as well. So let's be real clear. So when we set up this problem, we're going to set up 2.00 inches times inches. And now we need to use our conversion factor, which we looked at right here, because each inch is 2.54 centimeters. So we need to get inches on the bottom, centimeters on the top. To do that, we're going to say times 1 inch, or 2.54 centimeters. Hold on, let me erase that part. That didn't turn out very good. It really doesn't want me to erase that, so I'm just going to exit out real quick. Times 2.54 centimeters per inch times another 2.54 centimeters per inch. That's going to get each inch crossed out, and we're going to end up with 2 centimeters, which is what we need. So let's move this down a little bit. Okay. Boy, that was odd as well. Basically what we're doing is we're saying 2.0 times 2.54 times 2.54 is going to get us, and a quick calculation shows that's 12.9032. Now we have to look at significant figures. This number here has 3. The zeros are significant since they're given here. There are 3 in 2.54, so we're going to end up with 3. Our final answer is 12.9. So what we were looking at initially was 2.00 inches squared equals 12.9 centimeters squared. That's your final answer.